Okay, so the question is, when we use pop and when we say delete obsolete, are we deleting the correct node? Are we deleting the node that it's the one that we're supposed to delete? So let's basically take. Let me move it to this side, and so this is our pop function right here. And so again, the question to answer is, let me make sure that I'm recording this. All right, so the question is, how do we know that this is the correct thing to delete? So let's take an example here. All right, let's take an example here. How about, instead of doing those scratch drawings, I'll do some domestic, proactive debugging here. And before I delete it, this is what I'm going to do. std cout print obsolete. This is a pointer to the node, so it points to, and so print the data, right? And I can say deleting, I can't really type today, deleting this thing right here, so something like that. And we'll just show the data, and then the closing thing, and then maybe a new line and a semicolon, something like that. How about this? Okay. So we'll print some tracing messages. So here, what happens is that I'm actually going to print list. So the list will be printed. Then we should see what pop does. We never do the pop, but remember, the destructor does it. The destructor is supposed to call it. So let's see what happens. So it gets built. Now that we run it, so originally we say push 1, 2, 3, 4, 5. It ends up to be at the bottom of the stack because this is the first element gets pushed. Then we push 8, 8, 8, right? Then we push 7, 7, 7, and this ends up to be here. Then we essentially print. We print this. Right? This is the result of this print. Then we say return, and the destructor for st is invoked. So the destructor begins to execute right here, and it makes the series of pop calls. The pop calls here print this debugging message, and so here they are, those debugging messages. First, the root pnext is pointing to 777, right? So it gets remembered by obsolete, and this is the one that gets deleted right here. Then when we say remove next, as a result of that, the root is now pointing to this, because this was already excluded. But remember, the list doesn't manage any node lifetimes. The node only manages the links, which is next, 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 right? It doesn't bother to delete anything. It doesn't even know if anything is allocated by new or in any way of statically, not dynamically. So as a result, the next thing is that now root points to this one, And then as we keep looping in that destructor call, we say, all right, so root, what's your next? This, oh, okay. And so we're deleting the next one. So then finally we delete this one. So everything is deleted in the opposite sort of sequence from the top of the stack to the bottom of the stack. Good question, thank you. I do appreciate it. This is very, very much to the point. Any other questions about this so far? What else I would like to demonstrate? So as you can see, when memory is managed dynamically, when we start using pointers, and we kind of use we heavily use pointers inside of our root, we realize that in this very file, where in this header file where we're kind of recklessly writing all these functions in line, we realize that when push uses new, there just has to be a delete someplace that is reasonable, balanced memory management. So pop seems to be a logical place for this. There was some additional efforts to make sure that we do everything safely. We don't delete anything before we're still using it inside the node and things like that. But we were able to do that. And of course, we realized if we just let the stack go away and there is no destructor defined, then the memory is leaked. So it's not a good object that knows how to manage memory. So we decided to use this direct call to pop and say, hey, let's just routinely, as long as the size of this is greater than 1, just make sure everything goes away. Okay. Then here's something interesting. If this version of pop doesn't return anything, just doesn't, right? Then the question is, what's the purpose of this stack? How can we get to our elements? So the answer is brand new function top. So what top does basically says the implementation of top would be we have mroot, right? Mroot contains, this environment kind of nicely prompts for, contains data and some functions. So this data provides access to the data, right? So the root has the data. But we're not using root. We're using root only to manage the node. So therefore, pnext, root pnext is access to the node, at the beginning, looking from the root perspective. This is the next node on the list. So in that next node on the list, we can basically take and dereference it by using member, pointer to member dereference operator, this little arrow, and just say data, right? Just return this data. This way, I can say stack top equals, this is at the top of the stack, right? As far as I can remember. So let's change this to 1, 1, 1, 1, 1, right? So now, this particular function here, what it does is, it goes to the root and says, hey, you have a pointer to the node that represents something on top of the stack. And that top of the stack contains the data, so we can basically go to the data and essentially return a reference to it. So top returns a reference to an integer. If top is used on the left-hand side of an assignment operator, then this better be referring to some non-constant value in memory. And I was able to find it, right? So again, to illustrate real quick, is that we have this root object, right? So we have this root object, mRoot. It's the real node. So it contains its own data piece, but we're not using it because the root is used exclusively to manage the stack. But it has the pointer pNext. So it's pNext pointer here, pNext, right? pNext, something like that, points to hopefully another, data node that contains some value. So when we say root pNext, is basically this is this arrow. It's a pointer to this node on the list, which in itself can have more other pointers, but it contains the data. So we take this pointer, which is this root pNext, and dereference it and say, all right, you must have some data there. So let's use this data piece, which is another integer. Remember, inside the node, the data piece is just an integer. So we're using this integer to initialize a reference to an integer, and we return it from the top. And then so I can use the top to actually update the value that belongs to the stack. So I do have access to the stack directly to